Assalamualaikum and good morning, everyone. Okay, so today we're going to continue on our lecture 4C regarding the introduction to root locus. So on Monday, I have explained a bit about um, the use of complex number to represent the transfer function. So we can represent transfer function using complex number and also using magnitude and angle of the complex number. And I also show how to find, how to simplify a transfer function in the form of magnitude and angle. So today we are going to look at in more detail about what is root locus and how we can, how actually root locus is generated. Okay, the idea is generated. Okay, so let's look at an example of root locus. So let's say you have a camera, so a motion camera or a CCTV or any camera that can move. Okay, the lens can move automatically. So maybe this camera is put on the ceiling. Okay, so maybe the camera, the system of this camera has the following block diagram. So it has an input, which is the subject position and some sensor. And then the sensor will amplify. There's an amplifier that will amplify the signal from the sensor. And then the motor and camera, maybe this is the transfer function they derive. And this will provide the angular movement of this camera, and we want the output of the position of the camera, and maybe a unity feedback. Okay, so a unity feedback system. So firstly, before we can draw the root locus, we always simplify the block diagram. Okay, so we simplify the block diagram, find the closed loop transfer function. So we use the feedback formula for block diagram. Okay, so we then simplify further by assuming k a constant or a gain. Again, k equals k1 times k2. So this is our transfer function just now. So maybe because here we don't have the value of k, and so because we don't have this value, we cannot find the poles for this transfer function. So what we can do is we substitute different value of k, and then we find the poles for the transfer function. So for example, if k equals 0, then the poles will be s equals 0 and s equals minus 10. Then we repeat the process for k equals 5, equals 10, equals 15, and so on. Okay, so we increase the value of k, and then we find the poles. And then from here we can plot the poles in S-plane. Okay, so we plot all the poles here on an S-plane. So this is the black one here. The black poles here represent the value of poles when k equals 0. So when k equals 0, there are two poles. One is at 0 and one is at minus 10. And then we continue plot the poles for each different k value. So we got some shape here, okay? Then we connect all these poles. So we connect the first from the left here. We connect all the poles and then we go up. And the other one we connect from the right and then we go down. Okay. Either way is okay. Maybe if you can connect from right and then go up, or from left and then go down. Okay. Either way is okay. So the graph that we connect just now, the graph that we connect all the poles from different value of k is actually the root locus. Okay. So the root locus represent the paths of closed loop poles as we increase the gain value. So when we increase the gain k value, then the poles will also change. Okay. So in this case, the poles starting from -10 and from 0, it goes to a center here. So the center is at -5, and then one of them goes up and the other one goes down. Okay. So what can we learn from this graph? So from this graph, if we go detail, maybe if we check in MATLAB, so when k from 0 to 25, which is when the root locus is on this real axis, and then from here to the center here, then the system is always over them. Okay. So when you have poles on the x-axis, the system is over them. And when our k is at 25, or when your pole is at the center here, then your system will be critically damped. And then when we have k bigger than 25, so when your pole is not on the axis, so the system is under damped. Okay, so if you still remember your project 1, so all of your system, first order system, no second order system, is under damped. Okay, it's already given in the question, but I don't know, some 1 and 2 of all of you, including the other section, still say that your system is critically damped, even though it's already given it's under damped. Okay. So another thing that we can learn from this root locus is that all of the poles, when you change the value of k, all of the poles are located on left-hand side of the S-plane. So this is similar to what one of your friends asked on Monday, why we need to find the stability of the system when we know already from the transformation, it is always stable. Okay, so this is the case. Okay, it's always stable, no matter what value of k. Okay, fortunately lah, dia secara tiba-tibanya dia memang stable. Okay, but sometimes your transformation could be producing poles on right hand side of S-plane. Okay, even though you increase the k value. Okay, so all of the poles, when you change the k value, in this case, will produce a stable system. But the type of stability, either over damped, critically damped, or under damped, depends on the position of the poles. So if the poles on the real axis, it's over damped. If it's at this intersection here, or the center here, it's critically damped. And lastly, if it's not on the axis, it is under them. Okay, so I've shown to you an example of root locus. Okay, maybe next week we are going to go more about how to sketch the root locus. But for today, we are going to look at one of the properties of root locus, and in which how we can determine whether a pole or a point given to you is either on the root locus or not. So for example, if I said what is the point -7 on this root locus or not? So if you look at this graph, it's on the root locus. But if you don't have the root locus, how can you determine whether this point is on the root locus? So you need to do some calculations. So let's say you are given a unity feedback system. So the forward transfer function is this one, gs equals k times s plus 2 divided by s squared plus 4s plus 13. Okay, so we have the forward transfer function, but we don't have the root locus. So you can sketch or you can use MATLAB, but what happens if you don't have all of the sources? So now we want to determine, is this point -3 plus 0j is on the root locus of this unity feedback system? And then lastly, if this point on this root locus, what will be the value of k that pointing to this point on the root locus? So we can determine this by doing some calculation. So these are the steps. So firstly, we need to determine the zeros and poles of the forward transfer function. Okay, so this is applicable only for unity feedback system. Okay, unity feedback system. So first we determine the zeros and poles. So we determine from here what are the zeros and poles. Then we determine the angle made from the zeros and poles to the interested point or to this point -3. Then we determine the length of vector of this from the zeros and poles to this point -3. And then we add all the angles. So we add all the angles from number 2. If the angle when you add equals to multiple of 180, then the point is on the root locus. Okay, so it is based on angles. Okay. And lastly, to determine the k, we use the length, the product of the length of 0 and pole. Okay, so let's look at how we can do this. So step 1, we determine the zeros and poles of the forward transfer function, and then we can plot the points or the zeros and poles on S-plane. And also we plot the point of interest, which is -3 just now. So this is our transfer function. Then we determine the poles and zeros. So the pole, the zero is -2. Okay, so this is the 0. We represent 0 with a circle. And then we find the poles. So you can use a quadratic formula. So you get plus -2 plus -3. Okay. And we plot all of this on S-plane. And don't forget this -3 here. We also put it on the S-plane. So -3 is the point of interest. Then step number 2, we determine the angle made from the poles and zeros to this point of interest. So we can draw a line and then we determine the angle. So the angle is always measured from positive real axis, okay? Positive x-axis. So example, θ1 here is measured from positive x-axis. So you can use tangent or cosine formula or any trigonometric formula depending on how you look the angle, okay? So in this case, it is 270 minus tangent -1/3. Okay, it can be 180 plus or 360 minus. Okay, so it depends on how you look at the angle. Okay, so this is θ1 and then θ2. So this is you don't have to measure, it's 180 degree. Okay, -3 is just behind -2, so it's 180 degree. And then θ3, if you ada otak sikit, bijak sikit, you will realize that theta 3 and the angle from theta 1 here is actually symmetric, okay? Ataupun mirror image, a mirror image to one another. So you can simply 360 degree, or maybe you can just use theta 1 here and do something, okay? 360 degree minus theta 1. Okay, but in this case, it calculates again 90 plus tangent 1/3. Okay, but it's actually mirror image, okay, about the real axis. So we found all the angles. Then we can add all the angles. So if the angles when we add equals 180 or multiple of 180, then the point of interest is located on the root locus. So we add theta 1, theta 2, and theta 3. Okay, we add. So we add using the formula that I explained on Monday. So we add, for example, theta 1 is angle from poles, and theta 2 is angle from zeros, and theta 3 are angle from the poles. So we add poles and minus the angle of zeros, okay? Or we add zeros minus angle of poles. So if we look at this example, so theta 2 is the angle of 0 minus the summation of angle measured from the poles. Okay, so theta 1 are measured from pole number 1, and theta 3 measured from pole number 2. So we get the angle to be negative 180 degree. So it's a multiple of 180 degree. Then we can conclude that the point minus 3 plus 0j is located on the root locus. Okay, so always remember, when you find the angle, then to add, you add the zeros minus the angle of poles, or poles minus 0. In either way, you will get a multiple of 180 degree. If you don't get multiple of 180 degree, then the point is not on the root locus. Then next, we want to determine the gain k when the point is on the root locus. So firstly, we need to determine the length of the vector from zeros and poles. So again, we look at our sketch on S-plane. So we need to determine the length from the cross and circle here, poles and zeros, to the point of interest, which is minus 3. So the first length is L1, second length is L2, and third one is L3. So first we determine L1. So we just use Pythagoras theorem. So 3, the height here, 3 squared plus 1, 1 squared, square root, okay, square root of all that, you get square root 10. So L2 is just 1, okay, the length. And L3, as I said just now, it's a mirror image about real axis of the first pole here, the top one here. So it should have the same length. And then to determine the k, we use the length that we have calculated. So similarly, when you have the angles, you add and minus, okay? But for k, you have the length, you need to multiply. So we use the one that I explained on Monday. So L1 is the length of poles, similar to L3, the length of the pole. L2 is the length of 0. So to find the product, we find the product of length of 0 divided by the product of length of poles. Okay, so the magnitude M equals product of 0 length divided by product of pole length. So 1 divided by square root 10 multiplied by square root 10. So we get 1 over 10. And then to find k, we use this formula here. K equals 1 over m. So k equals 1 over m. So 1 over m is equals 10. So the gain k for the point of interest is 10. Okay. Any question before we go to tutorial? Okay, so we can try do tutorial number 10, okay? Okay, so let's try do tutorial number 10. Okay, so tutorial number 10, a unity feedback system with a forward transfer function is given below. So G equals 1 divided by S plus 2 times S plus 4. And then determine whether the point S equals minus 1, S equals minus 3.5, and S equals minus 3 plus 5J are on the root locus or not. And then determine if the points are on the root locus, determine the gain K. Okay, so assume that this transfer function actually has a gain K, okay? Okay, so let's write the GS first. Okay, so the first step, we need to determine the zeros and poles. Okay, step number 1. So from the transfer function GS, we know that the poles are minus 2 and minus 4. And the zeros. So here, if you look at the numerator, there is no S, okay? There is no S term. So you cannot find the zeros. So here, in this case, the zeros are infinity. Okay, there are no zeros, or the zeros are at infinity. Okay, not zeros equals 0. Okay, so 0 here is infinity. And then we can sketch these poles on S-plane and also sketch the points of interest. So we start with the first point of interest. So we start with S equals minus 1. Okay, so after we sketch on the root locus, then step number 2, we determine the angle made from all of these poles to the point of interest. So let's say theta 1. So let's say theta P1. Theta P1 represent the angle from the first pole, minus 2. So the angle made from minus 2 to minus 1, if we measure from positive x, Okay, so if we measure from positive x, it is 0 angle, okay? So theta P1 equals 0. And similarly, theta P2, which is from -4 here, also equals 0. Oh my god, it's multiple of 180. So we sum theta P1 plus theta P2 equals 0. Okay, tunggu sekejap. And then the third one, we determine the length. Okay, so before we determine the length, okay, okay, since you are not learning yet about sketching root locus, so actually, when you learn next week, you will see that the root locus here will have shape similar to example that I explained just now. Okay, so the shape should be something like this. Okay, so it will start at -4 and start at -2, going to a center, and then one of them going up, one of them going down. Okay, so the shape should be the red colored line here, and it doesn't cross -1. Okay, it doesn't cross -1. So -1 is obviously not on the root locus. Okay, so tak tahu apa jadi, but -1 is not on root locus. Okay, so probably it's multiple of 180, but it's 0, not a positive multiplication multiple of 180. So because of that, it's not on the root locus. Okay, it's 0, but it does not a positive multiple of 180 degree. Now let's look at second point. Okay, so since -1 is not on the root locus, so we don't need to determine the gain k. There is no gain of the system that causes the root locus to cross -1. Okay, because -1 is not on the root locus, so there is no gain. Okay, meaning that there is no system to produce poles at -1 if your system is this GS. Okay, so let's look at second point. When S equals -3.5. So similarly, we sketch again. Then we find the angle. So theta P1, it's under 80 degree. And theta P2, it's measured from positive real axis. So it's 0. So the summation equals 180 degree. Okay, now the summation of angle is multiple of 180 degree. So therefore, point S equals -3.5 is on root locus. Now, because of this point on the root locus, we need to find the gain. So we proceed with step 3. So step 3, we need to determine the length of the vector measured from each poles to the point of interest. So let's say LP1 is measured from -2, the first pole, to 3.5. So the length is 1.5. Okay. So how to get this? 3.5 minus 2. Okay. dia sepanjang ni, distance dia berapa. So it's 1.5 distance. And then the next one is LP2. The length measured from -4 just now, it's 0.5. Okay, so it's this length. Then we need to determine the gain K. So again, K equals 1 over M. So M equals the product of length 0 divided by the product of length poles. So there is no length 0. Bukan kosong, satu kot, toh. And then we have LP1 times LP2. Okay, this one I'm not sure. Okay, jangan ikut, okay. Tengok dulu apa jawapan dia. So we get 1 over 1.5 times 0.5. Calculator mana? So we get 4 over 3. And so our gain K is 1 over M. So again, it's 3 over 4. Okay, I'm not sure, okay, not sure. So we can check on MATLAB. Okay, check MATLAB. Okay, kenapa tak sure? Sebab saya tak pernah buat tak ada zero. Selalunya ada zero punya line dengan poles punya line. But this time no zero punya line. Itulah. Tak tahu apa jadi. But don't worry, this is just an example on how to use the concept of angle and length to determine whether the point is on the locus or not. And the third one is when the point is -3 plus 5j. Okay, so we sketch on the S-plane. Okay, so we want to determine whether this point is on the locus or not. So firstly, we determine the angle. So theta P1 is this angle. Okay, so we use tangent tangent -1 3 5 over 2 5 over 1. Okay, so this angle and then 180 minus. Okay, so use calculator. So the angle is 101.31 degree. And then we find theta P2. So theta P2 is measured here. So theta P2 is simply tangent -1 5 over 1. So we get 78.69 degree. Then we sum all the angles. we get 180. So the point s equals minus 3 plus 5j is on the root locus. Okay. Then we need to determine the length. Okay, so we determine this length here, L1 and L2. So L1 equals square root of 5 squared plus 1 squared. We get square root 26. So similar to L2, also square root 26. And then K equals 1 over M. So M, again, I'm not sure what are the top one here because we don't have the 0. So if you rajin, you check online game. L1, LP1, LP2. So we get 1 over 26. So our gain K equals 26. Okay, so this is the gain when the point is at negative 3 plus 5j. Okay, that's it. Any question before we end this lecture?
Sir,
Yes.
kalau dalam exam nanti dia akan bagi nilai atas tu kosong ke satu selalu? Oh, betul.
Um, selalu macam dalam nota. Dalam nota dia ada polls. Itulah siapalah yang buat soalan ni. Saya lah yang buat. Tak apa, cari dulu. Saya rasa one, dia akan kira one je. Tapi saya pun tak pasti. Tak apa, nanti saya cari. Saya akan beritahu balik.
Okay, sir.
So question, this kind of question actually come out masa bila lah? Last year kot. Tapi student out of 160, 170 yang jawab 2 orang kot. So they confused why suddenly the question asks whether this point on the rule locus or not. They don't even remember this method pun. Okay. So very rare lah soalan ni keluar. Tapi saya saja bagi soalan masa tu kan exam online first time ke macam mana dah. Sajalah bagi soalan killer. Alhamdulillah ramai tak jawab. So senang lah marking masa tu. So this is just for you to get the idea of determine whether a point is on the root locus or not. So first you need to determine the angle. Make sure the angle is 180 degree, the summation. And then to find the gain K, you find the length from each poles and zeros to the point of interest. Later on in lecture chapter 5, again chapter 5, we are going to use root locus to design a control system, a controller. So when we design a controller based on root locus, sometimes we want the system to behave exactly at this point, minus 3 plus 5j, for example. So at this particular point, minus 3 plus 5j, the system will behave similar to under dam type second order system. So we want to design a system to behave similar to an under dam system. So to behave as a under dam system, we need to determine a point in the root locus. So let's say we want to use this point minus 3 plus 5j, then to obtain the gain k, so we need to find using this calculation. We find the angle, we find the length, we find the gain K equals 1 over M. So treat this tutorial as an exercise for you to determine the angle and the length, because later it will be useful for you in designing a controller. Okay. Any more question? Okay, so what I want you to do now is to familiarize yourself with Raut-Hurwitz criteria and familiarize yourself with calculation of theta and length. In next week lecture regarding root locus sketch, these two root locus length and angle, and also Raut-Hurwitz criteria will be used a lot. And if you don't know about Raut-Hurwitz criteria or how to calculate length and angle, you might find yourself lost, okay, when learning in next week. So topik root locus ni dia macam curse lah. Setiap kali exam je student dia jadi gelong sikit. Tapi dia bagus untuk kita orang lecturer ni, sebab bila menanda tu tahu dah kosong, so tenanglah marking. Ada satu dua student yang memang boleh jawab. Tak semua lah. Ada yang boleh jawab, ada yang boleh attempt sikit, ada yang memang dia boleh jawab dengan senang je. Mungkin dia memang pandai ke apa, tak tahulah. So I want you to answer better lah in exam. So make sure you understand all of the concept for now, so that next week tak confused lah. Boleh cuba get along with the lectures. Okay, so that's it for today's class, and see you next Monday, insyaAllah. Assalamualaikum and goodbye.
Thank you, sir.
Assalamualaikum.
Thank you.
Waalaikumsalam, sir.